computer. Okay. All right, we're going to look at the next problem here, which is 1315. See if I can focus that in a little bit better. We have a 1,200 kilogram trailer is hitched to a 1,400 kilogram car. Okay, and that is what we see over on the right-hand side here. Okay. The car and the trailer are traveling at 72 kilometers per hour when the driver applies the brakes on both the car and the trailer. Knowing that the braking forces exerted on the car and the trailer are 5,000 newtons and 4,000 newtons respectively, determine A, the distance traveled by the car and the trailer before they come to a stop, and B, the horizontal component of the force exerted by the trailer hitch on the car. Okay, so as we look here, let's get this kind of set up. Okay. Out just a little. This is problem 1315. Mass of the trailer, 1,200 kilograms. Mass of the car, 1,400 kilograms. The braking force on the trailer is 4,000 newtons, and the braking force on the car is 5,000 newtons. Okay. We want to find distance to stop and B, F on car from trailer. Just kind of shortening it up there. We also know that the velocity that we're starting at is 72 kilometers per hour. And our ending velocity is going to be 0 because this is going to be the distance until we stop. Now, as we look here, we're going to use the work energy theorem. So we know that T1 is equal to, 1 to 2 is equal to T2, right? Our T2 is going to go to 0 because we're coming to a stop after we've applied our brakes. So for position 1, okay, we can say velocity 1 is equal to 72 kilometers per hour. Okay, and we need to convert that to meters per second. So if you convert, we're going to be 1 kilometer, 1,000 meters, 1 hour, 3,600 seconds. So our V1 should be 20 meters per second. Okay, and then we know V2 is going to be equal to 0. Okay. Now T1, as long as we're here, we can say T1 is equal to 1/2 times. Now, this is going to be the mass, right? 1/2 times mass times the velocity. So because these two are connected, right? Both of them are connected and they're moving along, we're going to take the mass of the car plus the mass of the trailer. We're just going to simply add those two together. And then we're going to multiply that by V1 squared. Okay. So this is going to be 1/2 times 1,200 plus 1,400 times 20 meters per second squared. So our T1 is going to be 520,000. Okay. That should be Newton meters. Okay. And then we need the work, right? So the work 1 to 2 is going to be equal to, now draw a little diagram here to make sense of this. So this is going to be the car. This is going to be the trailer. Trailer. Okay. We know that there's a braking force of the trailer, and we know that to be 4,000 newtons, right? We also know that there's a braking force on the car, and that's equal to 5,000 newtons. Now, the car and the trailer are going in the direction to the right. So the reason I have the force going to the left is because this is a braking force. So it's, stopping motion from happening. Okay, so it has to go in the opposite direction. It's friction force, basically. Okay, so when we look at the force over the distance, all right, we are going to be taking that braking force, and that's going to be the FT. That looks like tangential, capital T on the trailer, FC times the distance. And because they're going in a negative direction, that's going to be negative. Okay. So we're going to say negative 5,000 plus 4,000, okay, times D. So our U 1 to 2 is a negative 9,000 times D. And that's going to be your work. And so now to get your distance is the only unknown. So you're simply going to put those values in here, set it equal to 0, and you're going to solve for your distance. Okay, so that's going to be part A, and you should get a distance of 57.8 meters would be the stopping distance, but you've got to calculate that out. So that's part A, kind of getting that set up. Part B, which is where the question was, this one now, we want to know what is that horizontal force that the trailer pushes on the car with. So we will call that FH, and that's going to be the horizontal pushing force. Okay. Trailer on car. Okay. Now we're going to use the convention where we're going positive this way, like our normal convention. And we now know the distance that this is going to occur in. So we're going to look at the car separately because we're now interested in what is the force that's actually on the car. So let's draw a little picture of the car. We know its braking force on the car is in that direction. The distance for braking, we know, is 57.8 meters. And then there is this force horizontal that is coming from the trailer. So this is car. Okay. Now we're again going to use the work energy theorem just on the car. So we're going to say T1 plus U1 to 2 is equal to T2. And we know that T2 is equal to 0 because we're going to be stopping at that point. So we've got to figure out T1 and U1 to 2. We'll do T1 is first here. So T1 is equal to 1/2 mv squared. Okay, and that's going to be mv1 because that's where we're starting. That's where the velocity is. It's going to be equal to 1/2. And we know that the car is 1,400. So I'm going to put MC here, 1,400 kilograms. And we know that the velocity was 20 meters per second. So T1 for just the car, it's going to be 280,000. Okay. Work. Okay. I can get this over here so I can see them both at the same time. So our work 1 to 2 is going to be equal to, now we've got two forces here, right? And we're going to use our convention. So we're going to have FH, which is going to be the positive force going to the right, times 57.8 meters. That's our distance. Okay. minus FC, which is the braking force of 5,000 times 57.8 meters. That's its distance. So this is FC. Okay, so our unknown here is going to be the FH. So our U1 to 2 should come out to be 57.8 FH minus 289,000. Yeah. And now those are the two parts of the work energy theorem here. And your only unknown is that horizontal force on the car. And I'll let you guys finish that one up on that part too. Okay. Any questions? That should be enough. I think that should be enough to be able to finish that out. Josh, I know you had the question. Is that helpful? Yes. Okay. Excellent. All right, then I am going to stop the recording here for this one.